Hey, what is up everyone? It's your boy Fahad here, and I'm just basically, this video is going to be a review of everything I've been doing in my statistics class. It's just going to be a review of like a bunch of learning catalytic problems, and this is for all my friends who are taking stat, and hopefully it helps you guys out. I'm a very visual learner, so I broke this video down into like step-by-step procedures of how I approach these problems, and hopefully you guys understand everything, and if you have any questions, just let me know. So without further ado, let's get into it. For a certain group of cars, there's a strong association between city and highway mileage that can be described by the equation. So let's look at the equation. So over here, this is our y. Over here, this is our a plus b. And what is this over here? This is our x value. All right. So essentially y is the predicted response for any of the x values, and a is the y-intercept, and b is going to be our slope. So firstly, let's just approach the problem with logic. It doesn't really make sense to plug this in. We don't really want to predict a value of y using a value of x, which is out of the range, and this value of x, this is just ridiculous. So we're not even going to want to plug it in. This is going to be extrapolation, because extrapolation is essentially when we're predicting a point far out of the range. So yeah, none of these other answers would be plausible. There is a strong association between city and highway mileage that can be described by the equation. Okay, so this right here is going to be our y. This is going to be our a plus b, and this is our x. All right, so r squared is legit just r squared. So we're going to have 0.8 squared, which gives us 0.64. So we could get rid of options A, get rid of options B. Alright, so now it's just between C and D. So one crucial thing to know, let me write this down. So R squared estimates how much in Y Alright, so R squared estimates how much variability in Y can be explained by X. So Y can be explained by X. So let's take a look. Over here, predicted highway is our Y, and city MPG is our X. So we know it's 0.64, and we know that our y is the highway. This is our y, and explained by our x. So city MPG is our x. So this perfectly matches up. This doesn't. This is x, then y. So it's not C. So our only plausible answer is D. Alright, so for a certain data set, given that Q3 equals 62 and Q1 equals 42, which of the following data values would be marked as outliers on the box plot in StatCrunch? Alright, so let me just write a few things down. This is going to involve a little bit of math. So we've got to find our lower fence, which essentially equals our Q1 minus 1.5 times the IQR, and our upper fence, which is Q3 plus 1.5 times our IQR. And lastly, which is our IQR. So this is essentially going to be Q3 minus Q1. So it's crucial to keep this in mind. So what is our IQR? So Q3 is 62, and Q1 is 42. That's going to give us 20. What else? So now we're just going to plug in this 20 over here for the IQR. And for Q1, we're going to plug in that, and Q3, we're going to plug in 62. So let's do that real quick. So that is going to be 42 minus 1.5 times 20. Put that in our La Calculadora, and we get 12. So this is going to be our lower fence. So now let's do the upper fence. So the upper fence is going to be, we have 62 plus 1.5 times 20, which gives us 92 as our upper fence. So let's look at our answer choices. It has to be within the range of 12 and 92. So yeah, this is in the range, so it's not C. It's not an outlier. This is in the range, it's not an outlier. It's not D. So it's the only one that's out of range is A. For a symmetric bell-shaped distribution, the mean of the distribution was 20, and the standard deviation was 4. You would expect around blank percent of the data to fall within the interval 12, 28. Okay, so let's see what we could do here. So firstly, what is the standard deviation? It's how far away we are from the mean. So if our mean is 20 and our standard deviation is 4, let's subtract that, see what we get. So this is going to give us 16, right? So this is essentially one standard deviation. So now we have 16. If we do another standard deviation, we're gonna get 12, and this is gonna be our second standard deviation. And so we have 2 standard deviations right now, and we've achieved this number right here. So we could do that the other way around. We don't really need to, but 20 plus 4, 24. This would be 1 standard deviation. And 24 plus 4 gives 28. This would be your second standard deviation. So based on this, we know we have 2 standard deviations, essentially. So now that we have 2 standard deviations, we're going to utilize something called the empirical rule. So empirical rule is 68. 95. Let me just move this somewhere here. (68), 95, and 99.7. So this is our empirical rule, basically. And we know that 68% of the data is going to fall within 1 standard deviation. 95 is going to fall within 2 standard deviations, and 99.7 is going to fall within 3 standard deviations. So based on this, since we have 2 standard deviations, as shown here, we're going to be, it's going to be B, 95. Which of the following measures is most commonly used to describe variation in an extremely skewed distribution that possesses outliers? So let me write something down. So we know that for symmetric distributions, we use mean and the standard deviation. For skewed, we use the median and the IQR. So just based on knowing this, we know the measure of how we describe variance is through the IQR. So the answer is the interquartile range. However, let me just go a little bit more in depth on it. So we know that for symmetric distributions that, the mean represents a typical value. But for a skewed distribution is not really a good estimate for that. So that's why we use the median. So let me just quickly draw some of the distributions. So over here we have right skewed. This right here would be the mode. This right here would be the median. And this right here would be the mean. And let me draw a left skewed. This would be the mean, mode, median, my bad. And this would be the mode. So from this, what we know is for when it's left skewed, the mean is going to be less than the median. But if it is, my bad, if it's left skewed, it's going to be the mean is less than the median. Then if it's right skewed, it's going to be the mean is greater than the median. So that's just some stuff you should know about these different types of distributions. For a normal distribution curve, if the standard deviation is large, then the shape of the curve is... Alright, so this is actually a really easy problem, but let me go ahead and just draw it out. So let me just draw a normal distribution curve with a small standard deviation. So let me just put that here, and let me draw another one, which is going to have a bigger standard deviation. All right. So with a smaller standard deviation, it's going to look something like this. It's going to be more taller, and it's going to be not as wide. But if we have a bigger standard deviation, it's going to get more wide, and it's going to get more wide, and the shape of it is actually going to get lower. So the answer for this is A.